Cool. Everybody, welcome to Star Trek 2025. My presentation today is called Lights, Camera, Github Actions, and it is a non-comprehensive guide to getting your code going on the big screen. So a little bit about GitHub Actions. I think everybody here knows what GitHub is. Please raise your hand if you don't. I can't see anything anyways, so it's fine. So GitHub Actions is a continuous integration and continuous delivery platform based out of GitHub. And it's used to basically automate any kind of build, test, deploy, any kind of job that you can kind of think of. And it's very similar to platforms like Azure DevOps, Bamboo, AWS Code Deploy, and GitLabs. And so we're just going to keep going through here. My name's Nicole Hoying. I am a software developer, not a DevOps engineer. I have about 20 years of experience doing software dev, mostly in the .NET stack, full stack stuff, mostly, and also like some JavaScript, React, SQL stuff. And the reason I really wanted to highlight that was, like I said, I'm not a DevOps person. I am not like super passionate about DevOps, but I got a client assignment, which was a DevOps role. And this is where I kind of found GitHub Actions. And it really got me excited about a technology platform again for the first time in a kind of a while. So that's kind of why I'm giving this talk. I just want to kind of show to you that it's really easy to get into. And anybody with a software engineering background should have no problem picking any of this up. And then also you can see my cats up there. So my company made me put this slide in. You know, we got to have a little bit of an advertisement before the movie starts. I'm a consultant from Leading Edge. And at Leading Edge, we believe that technology is the most powerful tool for transforming businesses and unlocking human potential. As strategists, innovators, and partners, we don't just solve problems, we craft bespoke solutions that positively disrupt your business. I didn't write that. But Leading Edge is a really great company. I've been working there for about 6 years. We do all kinds of technology stuff, DevOps transformations. We do lunch and learn, so we'll even show up at your site and do a lunch and learn with you. Just a really great company, really great people. A lot of them are sitting here in the front row as well. So thank you all for the support. So we'll just go ahead and get started now that the advertisement's over. So you can follow along on GitHub. The link to the GitHub for all of the sample actions and workflows that I'm working on are up here in the GitHub link. I know we're in the AMC Easton. I know there's no Wi-Fi. I know there's barely any cell phone signal, so it's probably best just to take a picture of it and then follow along at home afterwards. All right, so you are ready to get started with GitHub Actions. So there's a few things that you need to do before you get started. The first thing you want to do is make sure that your repository supports the actions. So if you have a free tier account, it needs to be a public repository. GitHub won't let you execute actions on a private repository unless you're starting to pay for something. Then also you want to make sure that it's enabled on the settings. Pretty straightforward. Another thing, oops, sorry, I bumped my keypad. So workflows will only show up in the Actions tab if it exists on the default branch. So basically what I usually like to do is I will stub out a workflow and then merge it into the default branch before I start putting any actual code logic in it. So to create your stub workflow, you're going to want to put this in the .github/workflows folder. And you're going to need 3 top-level components to your GitHub workflow YAML file. And those 3 top-level components are the name, which is the name of the workflow that'll show up in the UI, the on, which is kind of the trigger action. This is what executes and causes the workflow to actually start, and the jobs, which is just the actual meat and content of your workflow. There's another layer there at the top layer called permissions, and you can use that to kind of filter out any kind of actions that you don't want your workflow going to do. So like if you don't want someone to be able to publish a package to your GitHub packages, you can just set the read permission for packages. The thing that you do need to be aware of with the permissions is that it starts out with the most permissive, but as soon as you set any kind of permission, it goes ahead and restricts all the permissions down to the lowest level of permission. So that might be a little gotcha as you're going through there. So once you have your workflow staged out or stubbed out, you can start working in it in a feature branch. And this is pretty easy to do. So we have a little example here. We have our workflow over on the trying to get my directions right. Your right side. Yeah. I don't know my right and left. I'm sorry. So we have our master branch on the one side, and we can see we just have a little drop-down box there. And then we're going to add an input into this. And so we just have a little bit of code there in the center. And then we check that into our feature branch. And then we can go into the GitHub Actions tab, select that feature branch, and now all of a sudden that input shows up. So any kind of code changes that happen in that feature branch stay in that feature branch. This way, if you're messing around with like a production workflow, you don't break the production build until you're done with all your testing. It's a really good way to annoy all of your coworkers to break the build. Everybody loves it. So, you know, we can deprive them a little bit of that enjoyment by working out of a feature branch. So with the triggers, the on keyword, like I said, starts the workflow. There's several different kinds of triggers in GitHub Workflow or in GitHub Actions. The workflow dispatch is kind of the manual way of setting things off. So this will allow you to execute it from the Actions tab. Push will trigger anytime you push a commit or a tag to the repository. A pull request will trigger anytime there's an action on any kind of pull request. So if you're doing a comment, an approval, if you're opening, closing, it's going to trigger that pull request trigger. So there's different like filter options because you don't want to like kick off tests every time someone throws a comment on a PR. You can also execute these on a schedule. And the format for that is just a cron job. So if anybody here is familiar with Linux cron jobs, it's the exact same format. And there's no inputs for these, but you can kind of code it in a way that looks at the github.event.schedule metadata and then write code against to look at like that cron job setting. So if you said you're setting a workflow to start at 5 in the morning and you need it to run in this environment, you can just write some code in there, say, all right, if the schedule equals 5 in the morning, then set it to this environment. And then finally, the last one I have here is workflow call. And that is basically used for reusable workflows, which is something that we'll get into later. Now that we've determined what our workflow name is and we figured out how we're going to kick it off, we're ready to actually script out what our workflow is supposed to do. So this is going to be putting in jobs and stuff like that. So jobs are kind of the core building block of a workflow. A workflow job is a collection of different actions that all run inside the same context. So that means that any kind of files that you build, any kind of binaries that get assembled, you can go ahead and reference those inside the same job. A job must specify a name, a runner, and a collection of steps and actions that you're doing. And then those actions and steps will run sequentially. If you need something that you create in a job, in a different job later on, you can upload those files as artifacts and then download them in another job later on. So picking a runner, so GitHub actually has 3 built-in runner types that are available for you outside of the box. They have Ubuntu, which is a Linux platform, Windows, and Mac OS. And depending on your GitHub account, you get a number of minutes per month. So a free account will get 2,000 minutes, up to an enterprise account will get 50,000 minutes. The thing is about GitHub runners is that not all of them are created the same as far as the billing goes. So Ubuntu will use your credits at 1 credit per minute. Windows will use your credits at 2 credits per minute. And Mac OS will use it at 10 credits per minute. So that's gotten me in trouble in the past. At my client, I was working on a mobile Ionic iOS build, and the initial build took about 20 minutes. I was messing with some stuff with the certificate for the App Store and trying to debug that. So I was running this workflow 15, 20 times a day. And it took about 20 minutes to get to this point where I needed it to be at. So it's we run it 20 times a day, 20 minutes. That's what, 400 points, and you take that times 10. So I was using about 4,000 minutes or so a day, or something like that. I exhausted the company's GitHub credits in about 2 weeks, and caused a minor panic amongst the DevOps manager there. And I was like, I swear this is not going to happen again. I got it figured out. Like, you don't have to worry. You don't have to worry. You can also use self-hosted runners, and those self-hosted runners can be on-prem. They can actually be out in the cloud. My previous client, we actually had AWS EC2 runners that we could go in there, custom create. We actually created an Active Directory joined GitHub runner for deploying SSIS packages. So there's actually a lot of stuff that you can do with custom runners and self-hosted runners. I don't know a ton about configuring them and getting them set up to use GitHub. That was a responsibility of a different team, but that option is out there. All right, so when we're setting up our steps and our jobs, we want to organize things so it runs in the right pattern. So in order to do that, we have to organize these dependencies. And we primarily do that with the needs keyword on the job. And so basically, we set up our dependency by saying needs, initialize. So this is kind of like a little example here. So we have our initialize step, and we have a build and test step jobs that are dependent on that initialize step. And then we have a deploy job that's dependent on both the build and the test step. And so I'm going to go into a little example here in a minute, but I also want to explain a couple other things that will kind of help with the organization. So if you have a dependency and that previous dependency fails, by default, anything down the chain is going to just cancel. It's not going to run at all. So if you have a step that needs to run, say it's a reporting step, some sort of notification job saying that, hey, the job's done or whatever, you probably want to use an if always or an if success or failure. And the difference between the if always and the if success or failure is that if you hit cancel, an if always will still run. But if you cancel the workflow out and you don't want that to kick off, then you want to use the if success or failure. So here's kind of an example workflow that I put together that kind of matches what we have going on earlier. And we have our workflow with our initialize step, and then we have our build and deploy. So GitHub will organize all these for you in the UI. And you can see here that the build and test steps run concurrently. So if they have the same dependency, it's going to run at the same time. If they have no dependencies, it's going to run at the very beginning of your job. And then you can see we have our deploy that needs both the build and the test step. That's in an array there on line. This is really small on my screen. Line 25. And so you can see that that won't kick off. So the nice thing about this being illustrated for you in the UI is if you have your dependency chain set up incorrectly, it's going to be very obvious when it renders on the screen because it'll lay out all that stuff for you ahead of time. So there's another strategy here for organizing your dependency, and that is a matrix strategy. And we can use these to kind of dynamically generate jobs based on different combos of like an array of a matrix, essentially. So the example that I have here is we have an environment and we have a server. So we have a dev, test, and prod environment, and we have an alpha and beta server. So we specify our matrix there on lines 10 and 11 by setting up our environments, by setting up our servers. And then when it hits that matrix step, it basically takes the 3 environments, multiplies it by the 2 servers, and we are going to get 6 jobs out of it. And so all of those jobs will run at the same time. You can actually use concurrency groups to make it so like the dev runs first, and once all the dev one succeeds, then it moves on to test, and once all the test one succeeds, it moves on to prod. And you can look up the options on how to do that. It was a little bit too complex for my example. Another thing that you can use this for is if you have to deploy like multiple items and you're not really sure what you're doing or what files are going to be there when the actions run. So bringing back up that SSIS runner, we had at the client, we had to deploy an SSIS package using GitHub Actions. And if anybody here is familiar with SSIS, it's kind of like a .NET project. Everything's in a solution, so you usually compile it at the solution level in Visual Studio, but the problem is that the tool that we're using only deploys it at the project level. So I basically wrote some code that looked for all the project files and then passed those project files in an array, and then I used a matrix strategy so that way any project file that was in that source code repository would get automatically deployed, and I didn't have to specify like this project file, this project file, this project file. So yeah, we can also use inputs for our workflows. So if we want to kind of change things up at the beginning of the runtime, we can go ahead and put that in there. And there are different kinds of inputs depending on the trigger actions that you're using. So a workflow dispatch will actually give you a little bit of typing with your inputs. So we have a couple examples here. We have a text input. At the beginning, we have a Boolean input, so that just shows up as a checkbox in the UI. And you can actually also do multi-select stuff. So if you're trying to use a workflow to deploy to multiple environments, you can list all those environments there as choice options in the input list, and they'll just show up in the UI for you right there. You do have to be a little bit careful because there's also inputs on a workflow call. And the problem is with the workflow call is everything gets passed in as a string input. So if you're passing Booleans back and forth and you're trying to check for true, you're going to actually have to check for the word true and not the actual truthy value or whatever. Usually that mixes up a GitHub Actions developer at least once, maybe twice, maybe 15 times in their career. And so when you have inputs, you can also specify outputs. And outputs are really great if you have something that happens in a build step that you need to use later on. So a big example for how I used outputs a lot was setting version numbers. And so using outputs is a little bit complex. I hope you're able to see all of that code up there. But I'm going to kind of sit here and squint and try to look at what I've got down here. So outputs are basically, you can set them a couple different ways. This example is using the GitHub output environment variable, and then we're using the append bash operator to push something into that output into that environment variable. So what you first have to do is specify that you're actually going to set up an output when you go ahead and create it. So if you look at lines 9 and 10 there on the code, we're referencing our steps, and then we reference the step ID, which is the set output step. And then inside of that, we have an outputs object that lists all the outputs that the step can produce. And then if you actually look there on the line 14, that's where we're actually pushing out to the environment variable. And so then when we go ahead and consume it, we'll need to use the needs keyword. So we have to set that previous job up as a dependency. Then we use needs. Then we use the job ID. And then we do outputs again. And then we specify the output that we specified there in line 10. Before I used like a little laser pointer to illustrate all that. That does not really do a great, I guess it doesn't do a decent job showing up on here, but that's not really going to help the people in the other theater, is it? talked about all the job levels. Now we're going to kind of get down into the nitty-gritty action details. So these are the individual steps that are inside the jobs that we're using. And so actions are kind of like your pre-written building blocks for your job. So there's a number of ways that you can produce actions. GitHub has a lot of them included built in under the GitHub/Actions. They have a GitHub marketplace that you can use to download third-party actions, and you can also write your own as composite actions. And actions will run sequentially in your job, and it basically has everything that your current context has access to. I have a little blurb up here above our little director guy here about logging. So if your workflow fails, you can get an option to rerun it, and there's a little checkbox there that says rerun in debug mode. But you can just enable debug mode by default by going into your GitHub repository settings, adding a repository level environment variable called actions runner debug, and set that to true. And then any action that you run inside that repository is going to use the debug level logging. So the built-in actions at GitHub, these are like your establishing actions. This is kind of like the main building blocks, the kind of like all the setup stuff that you need to do. So actions checkout, obviously very important. If you want to do anything with your code, you're going to have to check it out on your job before you can do anything with it. You can also use the checkout action to check out code in a different repository. So say you have some scripts or whatever in a shared repository that you need in order to execute that. You can reference that repository, pass it in a security token that has access to the repository that you're getting to, and then use that to check out that secondary repository. They also have these setup actions, and these basically install the SDKs for any kind of tooling that you're using. So they have like a setup node for Node.js, they have setup.NET, they have setup Java, and setup Ruby, et cetera, et cetera. This was really hard to type in .NET, by the way, on a Mac because it kept auto-correcting to botnet, and I thought that would be like really funny to leave in there, but GitHub Actions, I'm pretty sure you cannot use it to set up a botnet. They also have this thing called GitHub script, and I'm going to get into this a little bit more more later. But this is what actually got me like really excited about GitHub Actions. GitHub script is basically a Node.js environment that you can use to do all kinds of actions inside GitHub. And it gives you a few like few JavaScript objects that you can use to interact with your workflow. There's a we're going to get into it a little bit more, but like it's got a fully authenticated API client. It's got actions to your core stuff. So you can do anything that you can imagine you can do in JavaScript and Node.js, you can now do in your GitHub action. And then the other two major basic ones are upload and download artifact. And this is kind of the thing that I was mentioning earlier. So if you have a binary file or a compiled JavaScript file or something like that that you need to pick up and then drop into another job, you'll use the upload artifact, and then that'll upload it to your action, your job. And then that'll be available later on when you call download artifact. And you just reference the same name that you used for the upload, for the download, and then you also have to make sure that the versions match between the two. All right, so the GitHub Marketplace is a place where you can download third-party actions. And they are done by all kinds of different people. So you have kind of like major corporations that are doing it. You can see up here in the screenshot that I took, there's ones from Docker, there's ones from OpenAI. Microsoft, I think, has a Teams plugin as well. And there's also other ones from like just random third-party developers, random enthusiasts that like doing open source projects or whatever. And so there's a ton of stuff out here. So if you're doing like a personal project, you should have no problem pulling this in. If you're on an enterprise account, they might have this locked down. So at the client that I was at, they did lock this down. So anytime we needed to pull something off the marketplace, we had to beg and plead with the organizational owner in order for us to use that. Or these are also all open source, and you can kind of you can kind of look at the repositories and see what they're doing to get ideas on how to do it yourself. So yeah, I'm not going to give this slide the justice that it deserves, because when it comes to actually doing your builds, your deploys, your tests, all the stuff that's going on here, the main thing is going to be the run command. And this is basically running like bash scripts, it's running PowerShell scripts, any kind of command line thing. And it's really going to vary on your use case, right? So if you're building like a node package, you're going to be doing like your npm build here, you're going to be doing your npm publish. If you're doing .NET, you're going to be doing .NET run, .NET build, .NET test, .NET package. So it's, like I said, it's going to be very, very dependent on your use case. So I'm going to probably, like I said, a lot of your work's going to be in these run commands when you're actually doing stuff, and I'm going to spend about a minute talking about it. But depending on the runner that you picked, you have your ability to pick which kind of command shell that you're running from. So obviously, like your Linux runners, you're going to have access to Bash. I think on Mac, you have access to Bash and CSH, I think. For Windows runners, you have access to PowerShell, both the core and the base PowerShell. One of them is PowerShell spelled all the way out, and the other one is PWRSH. Please don't quiz me on which one is which. And so you can basically use that to kind of do, all of the commands that you need to do. There's also a Python one as well. So if you are a Python developer, if you really like Python, that's an option for you as well. But you can pass in environment variables into here. You can use kind of like the GitHub inline replacement stuff to kind of insert stuff in here. So this is really, really important as far as getting everything going and setting up. You can run AWS CLI commands here for like your publish stuff, Azure commands, all that stuff. So yeah, so when we're doing deployments, when we're doing any kind of stuff like that, we're going to have API keys that we need to manage. We're going to have URLs that we need to know to connect to do deployments. We're going to have, some sort of thing that's going to change from workflow run to workflow run. And so GitHub has secrets and variables. So obviously the main difference between the two is variables you can see in the UI and secrets you can't. So secrets are encrypted. You can't, once you put a secret in, you can't get it back out. And so GitHub offers 3 different levels of these secrets and variables. So you have something that you can set at like an organizational level. So this is the way I've seen this done is we had kind of a API token for GitHub that could access all the different repositories from place to place. And so we had that token stored as a secret at the organizational level. Then you have the repository level, so that applies to any action that runs inside that repository. And then finally, you can actually create like different environments inside that repository. So if you have like a prod environment, a dev environment, a test environment, you can have different values for those secrets and variables in there. And so the bottom level always supersedes a level above it. So environment secrets will supersede repository secrets of the same name, and repository secrets will supersede organizational secrets of the same name. And also, you want to be a little bit careful about passing secrets around. Like, you don't want to make sure that you put any of that stuff in a log file or something like that, so that way it shows up for someone to grab your API key. GitHub does a really good job if you're referencing the secrets.secret name to go ahead and obscure that for you. But once you pass that secret into an input, it loses that context. And so if you're using a secret in like a composite action, which is something we'll have to get into here in a little bit, you have to be very careful about that because you can inadvertently just dump your API key to a log, and then anybody that has access to that log is going to be able to see your API key. So yeah, GitHub scripts. So this is DevOps, but we're making it JavaScript. And like I said, this is kind of a very, very powerful thing that you can use here. You get a bunch of different objects that you can have that has like all kinds of cool stuff. Your main two are going to be GitHub and Core. So GitHub, the GitHub object, is a fully authenticated REST API client for anything GitHub related. So GitHub does a really good job of opening up every API that they have, so you can use it to list repositories. You can use it to list custom values for a repository. You can get a list of open pull requests and commits for a particular repository. So you can do a lot of stuff with that. The core object is used to just kind of set things along with that workflow. So you can set the status of the workflow. You can use it to set outputs. You can use it to read inputs, set annotations in your UI display. I'm going to go over the other ones here. I haven't really used them too much, so I can't really go into a lot of detail on it. Context has just basically different information about the workflow run. We also have these other three here. Glob, which is used to use glob patterns to find files. IO, which is kind of like a little bit of an input-output wrapper on some different functions. And then exec, which is allegedly something that you can use to run commands on like a cross-platform sort of thing. So if you have something that could run on a Windows runner or a Linux runner, and those commands are slightly different, rather than having to write out two different steps, you can kind of use GitHub scripts to take care of that. So I have just a really small, brief example here. It's not a great example of using GitHub scripts in a workflow. And so basically, we're checking out our script. We are going and we're getting our file system object, so we can write to a file. Then we actually have a JavaScript file that we can execute by passing in, whatever. And then we're passing in our GitHub and our core object, injecting that into our JavaScript file. And then basically we run our method. It generates some markdown stuff, and we write that out to a file. So one of the cool things about GitHub is that you can actually, GitHub has like the wikis, right? And you can actually use access a wiki the same way you do any kind of repository. So you can actually check out a wiki by just adding .wiki to the end of your repository name. And you can actually do commits and stuff like that and check in your markdown files and automatically push reports up to your wiki, all kinds of stuff with it. So what this is doing is we're going out here, we are going to execute this script, and we're going to write this markdown file and check it into our wiki. So that's kind of what's happening there from lines 19 through 26. And then when we have our actual script here, which is, like I said, a bad example because I'm not actually using the GitHub or core objects on this. But if you write your script out this way, it's actually testable. You can write Mocha tests about this because you can come up with mock GitHub objects, mock core objects, and then inject those in at the top, run tests. Testing in DevOps is really hard in general, so being able to write testable code using JavaScript files is kind of a game changer for someone that doesn't like to blow up the build very often. So we're going to kind of wrap up here with not repeating your code in GitHub. And the two ways to do that are composite actions and reusable workflows. And so we're going to start off with composite actions. And so the first thing we do is we create our file, and that's going to go in the .github/actions, and then you make a subfolder for the action name, and then it's always going to be action.yaml. And then we go in there and we just fill out the actions. We know we got to set a name, a description, and then we got to use the runs keyword at the base level. So we do a runs, and then we do a using composite. That has to be part of every composite action that you do. And then after that, you can just put in your steps that you need to run over and over again. So this one is doing it's just setting an output. Like I said, these are very basic examples. And then when we actually consume it, we'll reference it either by going to the organizational repository level, so like organization/repository .github/action/the action name at the version number. Or if it's inside your repository, you can just reference it directly. So you can kind of see there, so we have our composite action up on top, And then the code file that's here at the bottom, you can see where we're referencing it at, we're using the uses keyword there at line 12. And so basically, yeah, that just pulls out an output, sets it there, and then we can kind of rerun it as we go. So the other one is kind of reusable workflows, and this is very, very similar to actions. There's about 80% overlap between the two, but there's 20% of differences that are really important. So we kind of create it the same way. Instead of going in the actions folder, it just goes in the same workflows folder that all of your other workflows go in. We fill out the workflow just like any other workflow and just make sure that we have a workflow call on our trigger. And so yeah, then we just reference it. So we reference it there kind of just inside the job. So we define our job there on line 15. We use the uses keyword there on line 16, and then we can pass in inputs with that with parameter that's there on the following line. And so yeah, just very simple. You can go ahead and reuse that anywhere in your code. So like I said, there are some differences with that. Oh, this didn't save in the right way. So there's some considerations that you have to make with these things. So first of all, you want to be very careful with your checkouts. So if you are doing a checkout inside a composite action or a reusable workflow, and you're checking out a repository that isn't the calling repository, it's going to overwrite your previous checkout. So if I checked out something, say I checked out something in my Nicole.app repository, and I wanted to check out a shared script in like Nicole.shared. Once I check out Nicole.shared, it's going to overwrite anything that I checked out in Nicole.app. So you can use the clean false to bypass that on the checkout action, so you just got to be a little bit careful about that. You also have to be careful about your scopes. And so basically, your composite actions, your reusable workflows are going to be scoped to the repository that you're executing them from. So if I'm referencing a composite action or a reusable workflow in Nicole.app, it's not going to have access to any of the repository variables and secrets that are in Nicole.shared. So just be very careful with that. Make sure that you have copies of that either at your repository level, or if it's something that you need at an organizational level, make sure you get it set there. And then know when to use composite actions versus reusable workflows. And the slide here is going to kind of give a little bit of the differences between the two. So composite actions will allow nesting. So from a composite action, you can call a different composite action. And you can actually chain that down, I think, about 10 levels deep is what I think I remember reading. I've never gone that deep before. But a reusable workflow cannot go any levels deeper than that. So a reusable workflow cannot call another reusable workflow. It just will not work. It'll explode on you. Don't do it. So reusable workflows can use conditionals, whereas composite actions cannot. So like any kind of like if statements or whatever, that's not going to work in a composite action. And then composite actions can't access your secrets and variables. If you need to use a secret in a composite action, you need to pass that in as an input. And like I mentioned earlier, if you're passing in a secret as an input, you've got to be very, very careful that you don't accidentally log that somewhere. But workflows, a reusable workflow, you are able to like just do a secrets dot API key or whatever, and it'll reference that secret in the at the repository level of your calling workflow. All right, so yeah, that is my whole presentation there. Thank you all so much. Got a little bit of time for questions here. There's also a QR code here that Leading Edge has provided me for like feedback. So any kind of feedback you have on my presentation today, or if you want to follow up and do like a lunch and learn at your site or whatever, please scan that QR code, fill that out. And makes me look good or bad. I don't know. If you want to make me look bad to my employer, that's great. I'm more than capable of doing that myself. But if you want to help out with that, that'd be great. Thank you all for your time. Thank you all for coming out so early this morning, and I hope you all enjoy the rest of your conference. I can't. Yeah. The question was, does GitHub support containers that you can like run like SQL stuff? I believe it does. I've seen documentation to do it. I personally have not used it, but I'm pretty sure, yeah, you can spin that stuff up. My friend Liam up here's in the front where he's nodding, and actually I think we do use that at some stuff for at Leading Edge, an internal project. Yep. I can't see any hands, so. Oh yeah, looks like we got a couple Discord questions here. Let's see here. Are these all the questions? All right. All right. So we have Docker image tags as list in a manual workflow. Is this possible? Can they be read from ECR or something? And can they be used to populate a list used by workflow dispatch? Yeah, so if you can get a list from like a CLI command, you can basically export that out wherever it needs to go, and then put that in an environment variable, use it later. We were using that for we were actually using that for ECR. One of the things that I did in GitHub script at my last client was we would go run a ECR command in JavaScript using the AWS SDK, and then I would just go ahead and strip off the version number at the end of that ECR tag, and then that's how I knew which images needed to be deployed from test to prod. So yeah, that's very possible. We've got another one here. Oh my gosh, there's a lot of them. How do you run expensive build dependencies like Playwright, 4 GB instances? We've looked at building a self-hosted EC2 runner or using third-party services like Blacksmith. I have not particularly used Playwright. It was something that the client was starting to get into while I was there. I know you can use, I know GitHub in general has issues with like large files in general, which I think you can use GitHub large file format, but I don't know if that's going to answer your question or not. I'm guessing a self-hosted EC2 runner where you specify your own AMI that has that stuff built in is probably going to be the way you want to go. And I'm trying to think of the name. Philips Labs, I think, has kind of some really good GitHub runner base images, base AMIs that you can use and then you can build off of. We use that over at the client. It's an open source thing. I would definitely look into that. All right, visualize complex dependencies. Is there a built-in way to visualize a dependency graph if you have a complicated workflow or set of workflows, or a way of exporting and then visualizing a tool like GraphViz? I don't believe so. I've seen some pretty complex workflows. My last client, we actually had 2 big ones that were used to deploy over 120 microservices. And along with all of the AWS infrastructure to support all those. But I'm not aware of any way to like export that. It just looks really tiny with all the squares on the UI, and I don't know how much use that's going to be for you. And then non-deploy actions. Build, test, deploy makes a lot of sense, but is there anything yes. So build, test, deploy makes a lot of sense, but is there anything you've used actions for well and had them work really well? Yeah, actually, using GitHub script, we've done a lot of auditing. We automated a lot of stuff. So using the API actions, like the GitHub API, we were able to use GitHub Actions to generate a stale branch report. So we basically queried all of the repositories. We took a look at all the open branches, grabbed the last commit, looked at the date, and if that date was 6 months old, we sent an email to the author of that commit saying, hey, clean this branch up. So that's a good place for it. We used it for automating our any kind of like audits to make sure that we deployed the right stuff and all of that. So the slides also will be out on the repository or the GitHub repo that I mentioned earlier, github.com/nhoying/lightscamera GitHub Actions. Yeah, thank you all for your time. Enjoy the rest of your conference.